PID controller. Recall that we already went through the P parameter, which is the difference between my desired value and the actually measured or censored value. And I have my error, the difference between them. I also have my D, which is some sort of approximation of my future position. And this is computed by looking at the rate of change of the error. And now I want to blend in some sort of looking at the past. Consider that I have a system, say a big boat. Obviously, if I move the wheel, it takes some time because of physics, that the boat will actually react to my movement. But if I'm not patient enough, if I have no integral, no understanding of the time, I might do, well, there's no movement, so I'll do an extra movement of the wheel. Nothing is done yet, or not enough. And yet another wheel. Then now the boat will react eventually, so I need to fix it. And then I have this crazy thing. You can think of this, I don't know, your Hollywood movie you like, and in some, often enough in those movies, there's a car getting out of control, where the driver is trying to fix a crazy state by a very rapid movement, and it only makes things worse. So, in a way, is a way to restrict those rapid movement by adapting my past movement and somehow integral them. Another way of thinking of it, let's assume that this drone want to land on a moving target. So the car is actually constantly moving, I don't know, rightwards. The way to formally model those problems is that the drone is always behind the target, because whenever it takes the image of the target already moved. So the processing time takes some time, and there's a given gap. So in a way, the integral, the I, is a way to encapsulate the past. I integrate my error readings in the last, say, 10 seconds, or the entire past. And if they always seems to be behind the target, then I add them to the system. In a way, I slowly, but in a very mathematically sound way, I encapsulate the given error between the moving target and the actual position, so it will move like that. So I was able, by using integral, or integrate the entire errors of the past, to encapsulate those inaccuracy of a movement of a system. Those inaccuracy could be due to a big error in the dynamics of the big ships, so it takes time that the ship will actually react to my movement, or because of some time delay in processing, as in the example of the landing a drone on a moving target.